This video is solving by elimination method. Looking at our first example, we have a negative 6x minus 9y equals 0 and 24x equals 36y. What I want to do first, and what I always need to make sure I do, is I line up my variables. So my first equation has x, y, and the constant on the other side. I need to make that second equation resemble that with an x, y equal to the constant. So to do that, I need to move over the 36. Well, the 36y is positive. I do the opposite. That's not the opposite. The opposite by subtracting 36y. Minus 36y. Okay, so when I do that, I get negative 24x minus 36y equals 0. Okay, looking at it, I need to choose a variable to eliminate. In this example, I'm going to choose the variable x. So if I look at my variable x, I want it to be the same number but a different sign than my other x value. So I have negative 24x and a negative 6x. Well, if I multiply this first equation by a negative 4, that will give me a positive 24x, and it allows me to eliminate my x values. Now I have to multiply both sides by negative 4 because I have to keep my equation balanced. So negative 4 times a negative 6x is positive 24x. Negative 4 times a negative 9y is a positive 36y. And negative 4 times 0 is 0. I am going to now rewrite the second equation underneath it. So I have a negative 24x minus 36y equals 0. I need to add the two equations. So when I add them, 24x minus 24x is 0. That's what I wanted to happen. I wanted to eliminate them. But when I go to my y values, I have 36y minus 36y. That also gets eliminated. So I'm left with 0, and 0 plus 0 is 0. So when I get 0 equals 0, they're the same numbers. That's a true statement. What this means is I have two lines that are overlapping. So two lines that are exactly the same, which means I have infinitely many solutions. So any point that I choose on the line will make both of these statements true. Moving on to my second example. Looking at it, I notice that I have fractions. So I want to get rid of those fractions first. What I need to do is I need to look at my denominators, 9 and 18, and I need to find the least common multiple. And I need to multiply by that least common multiple in order to get rid of the fractions. Well, the least common multiple of 9 and 18 is 18. So I'm going to multiply both sides by 18 to get rid of the fractions. So when I distribute, 18 times 1 is 18. 18 times 5 over 9y is a positive 10y. 18 times a negative 7 over 18x is a negative 7x. By now you should know how to multiply by fractions so you can check my math. Now, the second thing I notice is that my first equation, it has the constant negative 24 and the x term, negative 8x, on one side and my y term on the other. Well, if I look at my second equation, I have my constant and my y term on the same side. So I need to do some rearranging to get my variables to line up. So I'm going to change the second equation since we're already working with it. I'm going to move my x term to the left side, my y term to the right side. Okay? So I'm going to start by moving my y term. So I'm going to subtract 10y from both sides. When I do that, I get 18 equals a negative 7x minus 10y. I am now going to move my x term to the other side, so plus 7x plus 7x. And it has the constant listed first, so I'm going to keep that. So I have 18 plus 7x equals a negative 10y. Okay, now I'm going to rewrite the first equation underneath this, just so I can see them lined up. Now looking at it, I need to choose a variable to eliminate. This is not one of the ones where I can just look and it's super easy. Some of you might think it is, but it takes a little more thought process. I'm going to decide to eliminate the x's just because I think it will keep our numbers smaller. And I have a positive x and a negative x, so I don't have to worry about changing the signs. So, in a case like this where I don't know where to go, what I would do is I'm going to take this first equation, I'm going to multiply it by the x value in the second equation. So I'm going to multiply by 8. Multiply by 8. So when I do this, 8 times 18 is 144. 8 times a 7x is a positive 56x. And then 8 times a negative 10y gives me a negative 80y. I'm going to now multiply the second equation by a 7. 7 times 24, or a negative 24, is a negative 168. 7 times a negative 8x is a negative 56x. And 7 times 12 is a positive 84y. So now that I've done that, I can take my two equations and I can add them. So 144 minus 168 is going to give me a negative 24. 56x minus 56x, those cancel out. I have a negative 80y plus an 84y. That gives me 4y. To solve for y, I divide both sides by 4. Okay, negative 24 divided by 4 is a negative 6. So y equals negative 6. Now what I need to do is I need to substitute this back in to solve for x. I'm going to go back all the way to my original first equation, and I'm going to plug that in for my y value, just in case I made any mistakes throughout this process. So I'm going to rewrite this equation. I have a negative 24 minus 8x equals 12y. But instead of y, I am going to substitute in the value I just found y to be, which is negative 6. So now I start solving. I have a negative 24 minus 8x. 12 times a negative 6 is a negative 72. I add 24 to both sides. I get negative 8x equals a negative 48. I divide both sides by negative 8. X equals a positive 6. So through all this work, I got an x value, I got a y value. I need to write it as a point, 6 comma negative 6. And this is my solution, meaning if I were to graph these two lines, they would intersect at the point 6, negative 6. Okay, moving on to our last example. It's not going to be as difficult as this one. I have a negative 5 minus y equals 2x. I have a negative 3 minus 3y equals a 12x. If I look at it, my variables are kind of already lined up. I have my constants, my y's, and then it's equal to my x terms. In this case, I want to eliminate the y variable, because I think that one would be the easiest. Okay, notice they're both negative, okay, but I want one to be positive. This is a negative 3, so I'm going to make this y right here a positive 3. To do that, I need to multiply this whole equation by negative 3. The negative changes the sign. The 3 allows me to multiply 3 times 1 and get that 3 value that I want. So I'm multiplying both sides by negative 3. And you have to make sure you do every single term to keep the equation balanced. So negative 3 times a negative 5 gives me a positive 15. Negative 3 times a negative y gives me a positive 3y. And a negative 3 times 2x gives me a negative 6x. This second equation gets to stay the same. So negative 3x minus 3y equals 12x. Okay. I'm going to now add my two equations because I have my y values to be the same number but opposite signs. So I'm going to add my two equations. So 15 plus a negative 3 is 12. 3y minus 3y cancels out. Negative 6x plus 12x gives me a positive 6x. To solve for x, I divide both sides by 6. So x equals 2. Now what I'm going to do is I'm going to plug that back in to one of my original equations. I'm going to choose the second equation. It does not matter which equation you use. And instead of the x value, I'm going to plug in 2. So I have a negative 3 minus 3y equals 12 times 2. So negative 3 minus 3y equals 24. I'm going to add 3 to both sides. So I get a negative 3y equals 24 plus 3 is 27. To solve for y, I divide both sides by negative 3. Y equals 27 divided by negative 3 is a negative 9. So I need to write my solution as an ordered pair. So x is 2, y is negative 9. Again, these two lines intersect at the point 2, negative 9. So this is a video for solving by elimination.